We studied a lot. We learned a lot. We learned about the basics of Python, using Python as a calculator. We learned that Python can basically work with numbers and it can work with more than numbers. It can work with strings, right? Strings of characters. And then you can put some of those things together into lists. You can make a collection, like a list or a tuple, and you can manipulate those collections, right? So those are the basics. But so far, we kind of have something that's a glorified calculator and something that prints some words, right? How do we use these things, right? So far, we haven't really done much that your calculator cannot do. Obviously there's the printing stuff, but how do we use it practically? So to get there, we will get there in the later notebooks, but there's a very, very good reason to use a programming language, right? And that is that you can make things, you can make things according to your own needs. You can customize functions, right? Calculators come with a fixed number of functions. You can, unless it's like a scientific calculator, you can't really define your custom functions. And even then, there are limitations to what you can define, how much data you can work with at a time. So a programming language on a proper computer gets over these hurdles. And to get there, the next stepping stone is to ask, what do we do when we need to repeat some code, right? So far, we have written some blocks of code. We have written little expressions. We have done our little assignments. We have run our little functions. But sometimes we need to do this over and over again, right? Now, there are two kinds of ways when it comes to repeating things, repeating a block of code. One could be repeating the block of code over and over again in the same place, right? So say you have to run the same function over a complete data set, right? Over a full data set. So you take every element of that data set, you throw them all in a list, for example, and you run that function on every single element, and you can do that in one place, right? Or you might need to run a block of code at some point and then do some other stuff and then come back to it and do it later, right? And besides this repeating, there's another thing, which is decision making. You may write two blocks of code and you can tell the computer to run one piece of code if one condition is met and run a different piece of code if a different condition is met, right? So that's where the conditionals and booleans come in. So we've learned about a lot of different data types, and we've learned about integers, floats, lists, strings. Now we're introducing something called a boolean. If you have learned about, if you know the basics of computing, you know booleans are the most fundamental variables. Everything is a 1 or a 0 in a binary computer system. So as you can see, there are two variables here. One is called true, and the other one has been assigned false. And you can see that the T and the F are capitalized, and they are highlighted in green because Jupyter recognizes the syntax as Boolean. So what does it give us if, say, okay, so I'm just assigning it at first, and then what happens if I print A and B? All right, so A and B would be true and false. What does that give us? Obviously, false, right? True and false is A and B. A and B is in true and false. It gives us false. What happens when we do A or B? Obviously, it should be true. Does it give us true? it does give us true. And if I print not A and not B, what should it give us? Not true and not false. So it should give us false and true, correct? Does that work? Okay, it works, right? So these are Boolean variables. There can be only two possible values, true and false. And Python has something called a soft data type, soft type setting. We don't need to get into that. Suffice to say, these are Boolean variables, and you can do Boolean stuff with it. You can do Boolean operations with it. Numerical comparison. We have learned about assignments using the equal sign. Now, what does it mean when what do we do when we have to compare things, right? So you can see that we have used something that's completely unnatural in regular mathematics, which is two equal signs, but, right? What does this mean in mathematics? Nonsense. But in Python, it does mean something. It is basically asking the programming language, is the thing on the left side and the thing on the right side the same? Are they equal? Okay? Are they equal? And the first one, obviously we know 1 is not equal to 2, so it should give us false. But the second one, you can see that it's an exclamation sign followed by an equal. Okay? Exclamation sign equal. Once again, nonsense in regular mathematics does mean something in Python, right? What does it mean? It is asking, are the two things not equal to each other? So we know 1 and 2 are not equal to each other. So that means it should give us true, right? Bingo. Okay. We are doing decision making. We are setting things up. Obviously, then we have something that is familiar in regular mathematics, which is the less than sign and the less than equal sign. And similarly, the greater than sign and the greater than equal sign. We know 1 is less than equals 2, and 2 is greater than equals 1. Anyway, I'm going to skip over that. Shamika, how many minutes do I have?
We're already at the time for notebook 2, but let's take another 10 minutes because notebook 3.
10 minutes.
Yeah.
10 minutes. Okay. I'll try. Give me a 5-minute heads up, will you?
Will do.
Okay, thank you. Okay, moving on. We are trying to introduce something called if-else statements. Okay, we know how to compare things, but how do we tell the computer to do one thing if one condition is met and another thing if another condition is met? And that's where if-else statements come in. So how does an if-else statement? We have defined something, defined a variable called x, and then we use the if statement. If a condition, we have defined a condition, is x greater than 10? If it is, then it will do this thing in the indent. Okay, you can see that there's an indent. There are 4 spaces here. Okay, or tab, or a whole tab, or 4 spaces here. Okay, and then we do else. Else is for when that condition is not met. If this condition is not met, okay, that's when this thing happens. Okay, 2 options. Either the condition is met, in which case this thing happens, or the condition is not met, in which case this happens. Okay, and remember, you should keep these indents consistent. You can do 2 indents. Okay, I can introduce another tab. It's fine. You can indent with only a single tab. Only a single space instead of 4 spaces. I don't like that. I think this looks cleaner. Okay, a tab looks cleaner. But anyway, we know x is not greater than 10. Okay, x is 5. So this condition won't be met. And instead, this will be printed. Does this work? Yes. It says x, in this case, which is 5, is less than or equal to 10. Okay, that's what it printed. Now, if I turn this into 15, you can see that the first condition is met, which is why it will print the first statement under the if statement. Okay, again, be careful with your indents. Doing this is fine. And it will work unless you have something inside the if-else statement. You can nest if-else statements, which is which we're going to get to next. And in that case, indents are actually very, very important. Anyway, so we're going to introduce something else called if-else, which is concatenated into a single statement called elif. Sorry, not if-else, else if. Okay. So whatever you want to check two different conditions. If condition is met, then it prints something or it does something. If condition is not met, then and only then it checks another condition. Okay. And if that condition is not met, it can move on to a third condition or it can go straight to the else statement. Okay. What if we want to do that? That's where elif comes in. We don't do another if statement, we do elif. Okay, so we have done x equals 10, we have assigned x equals 10, and this one condition for if x is greater than 10, this one condition for when x is greater than 0, and another condition for when neither of those conditions are met. Okay, so if I run this, you will see that x equals 10 is met. Sorry, x greater than 10 is met. So x greater than 10 is not met. That's why it goes straight to this, right? The second statement. It does not go to this, and it skips over this. It meets this condition, but it does not meet this condition. It does not meet this first condition, and that's why it moves on to the second condition, right? It prints whatever is here, right? X is greater than 0 or less than equals to 10, okay? What if I change it to 100, okay? Then the first condition will be met, and you can see that it doesn't go to the second statement, okay? It stops there. The first condition is met, so it just stops, okay? What if I do 0, okay? See, it went to the last statement because neither of the first two conditions were met. So using elif, you can check conditions in sequence. Jupyter, is that 5-minute warning?
Yes, sir.
Okay, great. We're doing good. Right. Next is loops. So you have to establish how to tell the computer to check for a condition and do two different things or three different things. And now we're going to look at something called loops. I'm going to skip over while loops. While loops are almost never used. And we don't use it in our notebooks. And they're kind of dangerous. I don't like them. So moving on, we're going straight to the for loop, which is the standard loop everywhere. Okay. So we have defined a list. My list 0, 1, 2, 3, 4. Sorry, 4 elements, right? There are 4 elements in that list: 0, 1, 2, and 3. 4 numbers, 4 elements. And we are defining a list. We are saying for I is a placeholder variable. You can see that we have not defined a variable called I, right? We have not defined a variable called I today at any point in this notebook. But we can use it here because for loops are special. Whatever variable name you use here, it doesn't have to be defined anywhere else. The moment you tell Python this, you structure a line of code like this, Python knows that I is supposed to be a placeholder variable. I is supposed to be the variable that the for loop uses to iterate over a collection, okay? So it says for I in my list, so if I is each single element in this list that I've defined my list, print I, okay? So if I run it, you'll see that I is printed one by one, okay? my list, every element of my list is printed one by one. The loop loops over the first time, it iterates the first time, it catches the first element, okay? It picks up the first element of the list, prints it iterates the second time, it picks up the second element of the list, prints it, and so on, okay? Until it has run out of elements, and then it just stops, okay? Safe and sound, nice little loop. What's the format? For a placeholder variable name in a collection name colon, and then indent, and then put whatever you want to do inside the indent, okay? Now you're going to see why indents are so important, especially in loops, okay? You can see that if I run the exact same thing, and then I put something outside the indent, so if I don't indent this last line with a tab, then the loop will run over only this statement and nothing below, okay? If I put the statement inside the indent, can you guess what will happen? Obviously, it will iterate over that statement every single time, and it will print all done 4 times. That's what happens, okay? Anything that I don't want repeated goes outside the indent. Anything that I do want repeated goes inside the loop by putting it inside the indent. I think we're coming up on the time. So I'm just going to show you a nested loop. As you can see that there's one for loop, and then there's another for loop inside it. And you can see that there are 2 levels of indent. So this is one level of indent. Okay, inside. You can see that whatever goes on in this inside loop, okay, this statement is repeated every time the inside loop iterates over the j variable, and this thing is repeated every time the outer for loop iterates over the I variable. And not only that, this entire inner loop is iterated every time over I variable, okay? We learned about range. Did we learn about range? No, this is the very first mention of range. Sorry, I'm just going to steal 1 more minute.
Yeah,
this
ahead,
always happens with notebook 1. Okay. So range is another collection. It's kind of like lists and tuples, but it's defined succinctly. Range just means a collection of, let's see, until just open a new cell and to show you range 2 will just show up as a range 0, 2. Okay, so I have to convert it into a list. And you can see that is basically equivalent to counting up from 0 to right before the end element. Because just like indexing with lists, it starts before the final element. Okay? And a range basically has 3 parts. I'm going to go with 6 and this. And once again, we can convert it to a list. You can see that a range is composed of 3 arguments. The starting point, the end point, exclusive. So the end point won't be counted. It will stop right before it reaches the end point. And then step, okay? So it counts from 0 to 6, excluding 6 in steps of 2, okay? That's what it does. You can get rid of the third element. You can just work with 2, okay? You can work with 2, and the default step will be 1. You can get rid of the first element, and you can just work with 1 argument. And it will assume that the starting point is 0 and count up to right before the argument, okay, in steps of 1. Or you can work with 2 arguments and set a custom starting point, and it will start counting from 1 instead of 0, okay? So that's range. This is a nested loop. So as you can see that the outer index changes from 0 to 1, and the inner index changes from 0 to 2. Okay, so outer index 0, outer index 0, 0, 0, and outer index 1, 1, and this should be inner index. Okay, and you can see that outer index 0. Okay, this whole loop, inside loop, ran 3 times. It printed 3 different values of the inner index, and then it printed that it is done with that value of I, which is 0. And then the outer loop iterated again, and for the outer index 1, the inner loop ran 3 times once again, the 0, 1, and 2, and then it once again printed, done with outer iteration 1. Okay? And that's about it. I will leave it here.